All right, bell work day 17, change 0.4 repeating to a fraction. So we've learned this before. All you need to do is see which place value your decimal starts repeating or it ends its repeating. So this one stops repeating in the tens place. Since it stops repeating in the tens place, we're going to set it first equal to x. And then we're going to multiply both sides of the equation by 10 so that we have our repeating decimal on a side by itself. The next thing we're going to do, since we multiply both sides by 10, we'll go ahead and subtract our new 10x from our old x. Or I'm sorry, the other way around. Okay? So then 10x minus x is 9x, and then 4.4 repeating minus 0.4 repeating. The repeating decimal part is finally gone, and 4 minus 0 is just 4. Finally, we're just getting x on the side by itself, so you'll divide both sides by 9, and then you have that x is equal to 4/9. And it is simplified, so we don't have to do anything else. All right, that is all for that one. Now that you've seen how to do it this way, go ahead and I'm going to pause the video now so that you can so that you can see if you get the next one correct. All right, go ahead. Okay, so the first thing we're going to do is set our repeating decimal equal to x. Then we're going to say, well, which place value does our decimal stop repeating? It stops repeating in the hundreds place. Since it stops repeating there, we'll multiply both sides of the equation by 100. And then we'll subtract off our original value from both sides. Okay, so then 100x minus x is 99x. And 27.27 repeating minus 0.27 repeating. My repeating decimal part is gone, and 27 minus 0 is 27. Finally, we'll divide both sides by 99, and we have that x equals 27 over 99. But it's not simplified, and we need to do that. So all we'll need to do now is just go ahead and simplify down as much as we possibly can. So I know they're both divisible by 9, so I'll do that first. So 27 divided by 9 is 3, and 99 divided by 9 is 11. And those both are simplified. They're actually prime numbers, so I know I'm done. So I found that x is equal to 3/11 as my simplified fraction. Okay. Approximate which two integers the square root of 30 is between. So we'll need to talk about the perfect squares now. So the square root of 1 is 1. The square root of 4 is 2. Then I have 3, 4. Square root of 3 is equal to square root of 9. Square root of 16 is 4. Square root of 25 is 5. And the square root of 36 is 6. Clearly, the square root of 30 is going to lie between the square root of 25 and the square root of 36, and those two integers are 5 and 6. Finally, number 4, place the square root of 2 in the appropriate place on the number line. So the square root of 2 is going to lie between the square root of 1 and the square root of 4. Well, if I'm looking here at 1.5, that's going to be the halfway point. So it's probably, and what's between the square root of 1 and the square root of 4? It's probably going to be about the square root of 2.5. So since I know that, my answer is probably going to lie somewhere here between 1.3 and 1.5. So we'll go ahead and square all of these to see which one gets us the closest to the square root of 2, or closest to actually 2. Okay, so 1.3 squared is 1.69, little too small. 1.4 squared is 1.96. It's almost exactly our 2. And then 1.5 squared is 2.25, too big. So we would say that our irrational number of square root of 2 is probably going to be somewhere, and I'll erase this. It's going to be somewhere, it's going to be almost exactly 1.4, but a little bit bigger. So we'll place our point here. And that is all for today's bell work.